How is it everything working at the same experience? You're really no. It's like wow. Why are we jumping from 9 to 8?
We're doing practice today.
But we can give her all explanation. They're always on there. Not last. We have recess. For sure. Wait, what page?
So today, I just want us to practice solving different equations, as well as going back and doing some more of the slope fields. Okay. So we'll just split our time between these two things. So if we want to solve a different equation, well, first we're going to find a general solution. And then once we get it down to general solution, we can focus on the order pair and pick our particular solution. All right, so we'll walk through it step by step. Okay, so first thing we can do is let's get that y prime to be in a different form. Y prime can be written as what? Y dx. So I'm always trying to see if I can get two fractions to equal each other. So I'm going to go ahead and add that xy cosine x squared to the right side. Okay, this still looks kind of messy. I'm going to put a divided by 1. I'm going to just go ahead and cross multiply. I'm not trying to separate the variables just yet. I just want my dy dx's in their positions, or in their where we want them to be on separate sides in the numerator. Okay, so we know that the dy dx's are locked in. We're not going to move them at all. They're where they need to be. So make sure you don't divide by dy or divide by dx. If you're going to move anything, you're moving things around it. You're not going to move the dy or dx. Okay, so now we take a step back and ask, do we have full separation of variables? Okay, what's the one thing that's out of place? The y. So what do we do with the y? Divide. So if I divide, where's it going to end up? Denominator. Okay, so make sure you don't see that y down there and push it to the numerator. Okay, we do have a rule that can handle y in the denominator. So if that's where it ends up algebraically, that's where you need to keep it. Right, full separation of variables. Now we can take the antiderivative. Okay, so left side here, 1 over y dy, what does that turn into? Natural log. Good, that's the value of y. Now the right side requires a bit more work here. We got to go through what process before we can take the antiderivative. Good, use substitution. What's our u value? X squared, right? We can't separate this and say, okay, that's power rule and this is cosine, which is sine. This is all connected, right? We got to go through u substitution. We're hoping that this will clean up to be a rule that we can recognize. So off to the side. cross multiply and divide dx equals du over 2x. Not ready for the antiderivative rule yet. I still want to do some cleanup here. So x cosine of u times du over 2x. What happens here? X just goes away. What comes out in front? 1/2. Do we have a nice rule for this cosine u? Yes, cosine becomes sine. And then replace this u back in terms of x. Okay, so now we're at the same level. So the left side is taken care of. The right side is now also taken care of. Plus c. Okay, let me reset and bring this up to the top again. So we're basically at the function level, right? We're done with the calculus. Now I'm just going to try to solve for y and try to get to my general solution. And then I can worry about the c later when I try to find the particular solution. All right, so I want to solve for y. What can I do to get this natural log to go away? Both sides base e. This side goes cleans up, absolute value of y. Okay, thanks. Now, everything is up in the exponent level. We're going to take advantage of this property that we have. If I have a to the m plus n, I can split that up into a to the m times a to the n. So I'm going to split that c apart from my variables. Now, careful with this operation here. This plus is going to turn into a what? Multiplication. So it comes down as times e to the c. So everybody see how we applied this property to get from here to here? This e to the c is just one big what? One big c that we can just pull out in front. The absolute value goes away because plus or minus is going to show up on the other side, but the c will just take the plus or minus in. Okay, that's part A. That's my general solution. Okay, any questions so far? Part A. Okay, so now part B, it says find the particular solution. Now we can just plug 0 in for x, e in for y. And this will allow us to solve for what? Yeah, I'm trying to solve for c. Okay. Sine of 0 is just 0. E to the 0 is 1. So c is equal to e. Now I'm going to just insert e back into my equation. Yeah, you can definitely leave it in this form, but I just want to show you a more simplified version of this. I can merge these together. So this is kind of going backwards from this property, right? If I have the product of two variables, I can merge it together and add the exponents, right? So I can Because I share the same base, I can just merge the exponents as additions. So y is equal to e to the 1/2 sine x squared plus 1. And these are all fine. If you leave it in this form, that's perfectly fine. But I just want to show you this version of it because imagine if it was like on the multiple choice section of the AP exam, and you got to this point, but your answer choice is showing this. You want to be able to see that connection between these two. Okay, let's go to number 3. Yeah, so over these next 2 days, I just want to show you as many different variations of differential equations and see if you can get some more practice. Okay, you guys want to try this on your own and see how far you can get, and I can follow up with the steps. Okay, so rewrite, get that dy dx to show up, get 2 fractions to equal to each other, cross multiply, get your dy dx's in the right spots, and then through a series of division, you want to get full separation. Anything related to y is on the left, anything related to x is on the right. And this one, you're just getting to the general solution. No particular solution for number 3. Okay. Any questions up to this point? Okay, what's out of place? X and the y. So what do we need to do with both these variables? Divide. So this x is going to be in the denominator on the right side, and the y is going to be in the denominator on the left side. I'm going to just do a double division on both sides. They're both going to move to their respective places. Going to make them swap. And they're both going to land in the denominator. Do we have full separation? Yes, everything's in the right places. The dy dx's are good. The y and x is okay. We can handle these variables in the denominator. We don't want to just make them float up to the top. They belong in the denominator. Okay. Okay, so the left side is just going to be what? 1 over y natural log. That's pretty easy. This one, we're going to go through U substitution, but we need to do something. We need to do some rearranging first. This fourth is a little bit out of place. Where else can we put a 4 with a natural log problem? We bring it down in front. That will make the problem a little bit easier to manage here. So this becomes 4 natural log of x over x dx. And I can push that 4 out in front. So this is natural log, right? But this right side, there's no rule that can handle this individually. So we got to go through U substitution, right? So any guesses as to what the U value could be? Yeah, the natural log of x. Because what's the derivative of natural log of x? 1 over x, and that 1 over x is perfect for that x that we see below. So we're looking ahead and to see if there's a nice match with my U value, and there is. So that's my process. Okay, integral of U, what rule do we use for that? Power rule, yep. U becomes U squared over 2. Make sure you bring back your x. I do want to point something out here. Can this 2 come down in front? No. Okay, so I want to make sure that we understand this. If I had natural log of x squared, I can bring that down to be 2 natural log of x. But if I have natural log of x quantity squared, I cannot bring that down in front. Okay. So that's a very subtle but important distinction here, right? That this fits with the power property, but this, if I bring that 2 down, I'm completely changing the expression. Okay, so that 2 has to stay there. We can't do anything there. Okay, so I have all my calculus is done. I just have to solve for y. What's my final steps here? Involve what? Involve e. This goes away nicely. Separate that c away from that e. The reason why is because this is not quite a clean relationship because the 2 is involved. The 2 is involved here. So we can't skip all this and just cancel these out. We have too many things in the way. Now, if it was just e to the natural log of x, then yeah, we can clean that up. But the 2 and the square, that's too much. It's not a clean relationship. So we have to just leave it alone. Okay, we know that just turns into a big C. Pull that C out in front, drop the absolute value. Okay, next page, page 18. All right, see how far you guys can get. I've got the key attached and a little bit past these pages so you can check your answer as well if you're ahead. First, just focus on trying to solve for y or solve differential equation. Don't worry about that order pair 0, 5. That's not going to come until much later. Y just hangs out in front. And so you can get two fractions show up cross multiply. Yep. So you put that over form over that this y is something with the y. Now you can see two here, but each bracket is cross multiply. Worry about that much later. Yeah. Once everything is set up and cleaned up, you should decide that that's the place. Well, with that y, y has become y squared over 2. Right, but there's one over y that is not y. So in this problem, the y is going to end up in a numerator. Just because algebraically that's where it ends up, and you're not going to force something that doesn't, right? Sometimes the y is in this denominator, sometimes the y is in the numerator. Algebraically, if you're following the steps appropriately, then you're just going to handle with wherever it lands. So left side here, we got to go through our rule. And the right side, you got to go through a little bit of what? U substitution, right? And your U value is 3x. Eventually, that's going to turn into an e to the u rule. That's y squared over 1. That's how it will be. 1 over y is natural log. Y is 1 squared over 3. Yeah, that's down the road. Yeah, we'll deal with that later. But right now, I'm just trying to take the antiderivative, and then from there, we'll decide what to do. We'll play everything back to the Yeah, I think on my key, I did it a little differently than what I'm going to do here. So up to this point, we went through use substitution. Got 3x, we took care of it, du over 3. That 3 is in the denominator, 2/3 get pushed out. Y becomes y squared over 2. So this one's clearly power rule. 2/3 e to the u. E to the u is just e to the u. So bring the x back into your problem. Okay, everybody good up to this point? So from here on out, you can do, everyone can take a different path, and that's fine. So ultimately, you want to solve for C, and then you want to solve for Y. So you could do them in any order you want. You can solve for Y first, then solve for C. You can solve for C at any point once that C shows up. So just to let you know that you may go through down a different path from here, and it may not look like mine, which is fine. Okay, but as long as you're able to end up at the same place, that if we all end up in the same place, you can do whichever way you like. But for me, I like to try to get this a little bit more cleaned up. I want to get that 2 out of the way. So I multiply everything through by 2. And then the 2c, I'm going to just clean that up to be just plus c. So to me, this feels like a relatively easy equation, because eventually the square root shows up. It feels a little bit more complicated there. I like to solve for c at this point, but you definitely don't have to. To me, it just feels the cleanest place to solve for c. But you can solve for c earlier. You can wait till you solve for y, then solve for c. There's like a lot of different variations that you can do from here, but I just want you to understand that not everyone may see things the same way, which is fine. I'm going to plug in 0 in for x, 5 in for y. In fact, I don't think I did this the same way on the key when I created this. So 25 minus 4/3. So now I'm going to take my equation, replace c. Now I'm just one step away, square roots, right? Take the square root of both sides. What's going to show up? Plus or minus. These are two solutions. How do I know which one to choose? I look at the y value. The y value is what? Positive. So therefore, I want to choose the positive square root. Well, if I take the square root of both sides, the plus or minus is going to show up on the right side. So if I have like y equals x squared, plus or minus just shows up on the right side. All right, here's the messiest one here. Let's go back to page 15. So what feels more complicated about this problem is the fact that we don't see x's and y's anymore. Okay. So, but if you don't see x's and y's, then it's always going to be time and something else. Okay. So basically, x is going to be replaced with t, but your y can be any variable. Okay. Whatever the dependent variable is, it could be b, it could be z, it could be w. But just understand that we're always dealing with an independent and dependent variable. Your x is going to be t, and then your y is going to be whatever variable we see in the problem. So in this case, we're going to treat t like we do x, and we'll treat b the way that we treat y. I've had some students ask, oh, can I just rewrite this problem in terms of x and y and then bring it back in terms of these variables? I think it's too much trouble. I think it's just easier to just kind of practice understanding that we can treat t the same way as x and treat b the same way as y. Right, so it says the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. So that's created by this equation that they've given us. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams, then dv over dt equals 1/5 100 minus b. Let b of t be the solution to the differential equation. So we know the differential equation because we see the derivative here, and the initial condition order pair is 0, 20. Use separation variables to find y equals b of t. So we're going to separate the variables, take the antiderivative, solve for b, and then plug in the order pair. Okay. So let's go through our steps here. Now I'm going to force both sides into a set of fractions. That step makes sense. I'm just putting that 5 in the denominator, but I'm just setting myself up to cross multiply to get the dv and dt in their right spaces. And also, by the way, if you ever see a differential equation, it's always x and y or time and something else. Okay? You're never going to see any other variation. It's only going to be those two. Okay? But it just looks more complicated here because you may see a lot of strange variables that you don't recognize, but just whatever is strange, just treat it as the quote unquote y. Bring that back there. Okay. Okay, cross multiply. Okay, so I want us to see that the dv and dt are nicely placed, right? So they are where they need to be. What's out of place? But if we want to move the b, we have to move what along with it? 100, yeah. So we see the set of parentheses. Also, this is, I created parentheses here to separate it from dt here. So we have to understand this is all connected. Okay, so the 100 minus b has to go over. What else could we potentially move? Yeah, the 5, it's okay if you leave it on the left side, But I always say that you want to leave the left side as minimal as possible. So anything that doesn't have to be on the left side, just go ahead and move to the right. So again, I'm going to do a double division here. The 100 minus b is going to be in the denominator on the left side. And also, I'm also going to divide that 5 over to the right side. Okay, everybody goes from here to here. Now I'm going to just rewrite this in different form. I do have full separation. It does feel a little cleaner if I write it out this way. That 5 I can push out as 1/5. So the right side is clean, power rule, right? 1/5 integral 1 dt. What does 1 turn into? Is t, right? The 1/5 stays. On the left side, you got to go through a little bit of what? U substitution. What's my u value? 100 minus b. Yeah. So b is the variable. We're going to treat b like y. So if you see your strange variable here is your y, t is your x. Yeah. So I think that's something that we got to get used to with these problems. It's easier if it was x and y, but with these word problems, a lot of times they're using time and something else. So we'll treat t like x, and we'll treat b like we would do y. Okay, 100 goes to 0, negative b becomes what? Negative 1. We're trying to get everything in terms of u on the left side. Pull the negative 1 outside in front. Okay, so now natural log on the left side, power rule on the right side. Okay, I'm gonna reset here. I'm gonna put this up to the top. Okay, I want to solve for b. What can we do? Yes, we do want to involve e, but there's something that's getting in the way, the negative. So what can I do with that negative? Yeah, or multiply by -1, right? So if I just distribute the negative through, I want to get that left side to be a clean natural log, because e to the negative natural log doesn't quite have that nice property that we want. And I'm still leaving that as a plus c, because c just represents all positive and negative numbers, so I don't have to change the sign there. Now I can involve e, because now I have a nice clean relationship here, e to the natural log. I'm trying to get that absolute value to that natural log to drop. Separate the variables. I mean, separate the c away from the variables. I dropped the absolute value. I pulled the C out in front. And now I want to solve for B. So B is equal to all right, so this is my general equation. The particular solution we can plug in what order pair? 0, 20, yep. 0 in for T and 20 in for B, because our whole purpose is to solve for C. The 0 is nice. That's just gonna force that to go away. So then if I solve for C, C is equal to 80. Now I can update my general to a particular solution. Sorry, I lost 5. A lot of algebraic steps going on, but I want us to get a feel for this is as hard as a problem can get in terms of the algebra process. Yes.
If we did positives, because you said like the negative or positive doesn't matter, right? Does it matter there?
In this case, it does, because C is not by itself. It's involved with that 100 here. So we do need to keep that we do need to keep that as a negative here. Because it's not just a C by itself. That 100 is involved in this process, so we do need to hold on to that, because it's within an expression now. It's not just a C by itself. Okay, so today I just want us to get some more practice with differential equations. Tomorrow, we'll do some more practice with this, but I also want to go back and revisit some of the multiple choice problems involving slow fields. Okay, so we'll do some slow fields tomorrow and some more differential equations. Okay, go up and get your phones. Go up.
I should have thought. So I like did it and then I looked up and then I was like, I know I went wrong somewhere, but I'm not sure where. So I had 100 minus 3 equals this, and then I subtracted the b, so I moved it over here. And then when I like canceled out this, I got a positive 100. That's right?
Yes, yeah, that's right. That's right.
Okay.
Because I had a positive 100 as well. I just put 100 first. You just put the
Okay.
negative C. So this looks right.
So my final equation, this is what I got.
Oh, let's see here.
Because even if I had the 100, even if it was b equals 100, it would be plus 80. So I'm just like confused.
Yeah, let me see. Why do we not line up? We're good up to this point.
Yeah.
Yeah, that's good.
No.
Yeah, this looks good. 20 goes here. 0 goes here. Equals negative C. C is A. C is A. Okay. So you made the substitution at this point,
Yes.
right? You plugged in 0, 0, 20. So if you did that, that means once you solve for C, you got to put it back where you made that substitution.
Okay. Oh, so okay, so even if it's positive 80, the value is still negative
It's,
C.
yeah, because you
Okay.
replaced the 80, but there's still a negative here, so you got to hold on to that
Okay.
negative.
Okay, I understand now. Thank you so much.
Here.